Howdy students, this video is going to focus on dimensional analysis, which allows us to convert one unit into another. We're going to use a problem solving called dimensional analysis. We're going to have to use equalities, or what we call conversion factors, and I believe most of y'all are familiar with some conversion factor, one or another. This allows us to go from one unit into another. So here's a quick example, not in your notes. If someone gives you 32 quarters, how many dollars do you have? Well, a lot of you would say 8 right away. But how did you know that? You needed to know that for every $1 equals to 4 quarters. And that right there is what we call a conversion factor. So we're going to practice this, and we're going to learn how to calculate. How many inches are there in 4 feet? Right away, probably some of you are saying, oh, 4 times 12, 48. But how did you know that? What did you have to know to figure it out? 1 feet equals 12 inches, and that's our conversion factor. It can be written as a fraction where the numerator and the denominator are equivalent but have different units. For example, this is how we can write them in our method for dimensional analysis. You'll notice that you have 12 inches over 1 foot here, but on the other side you have 1 foot over 12 inches. So we can reverse the two. And they're both perfectly good equalities. You might need to use one of them or the other depending on the situation. So let's give that a practice. Practice converting 24.00 years into weeks. Now, real quick, a note on sig figs. It looks like this is some sort of measurement because of the decimal places. I'm going to be telling you which numbers to take as significant and which numbers are exact numbers, which means you can leave them, you can exclude them from your rounding rules in the final answer. Okay, here's our conversion factor. 1 year, I'm giving it to you. Sometimes you'll be able to use your own. I'm just going to go straight from years to weeks so we can show you how to do this problem. We're going to call this the train track method or the T-table, one or the other. So I'm going to start with 24.00, and I need to write the units, years. And then I'm going to draw a line, and I'm going to include my first conversion factor. You'll notice that nothing goes on the bottom here. And until we see our second video, part 2, over converting multiple units, nothing will go on the bottom. This is our first conversion factor. I drew a line to separate it out. Years was on the top of my train track. So to get rid of years and go into something new, I have to put years on the bottom. Only then can the units cancel. My equality is 1 year equals to 52 weeks. So I have gone into a brand new unit, weeks. And is that what I wanted in the question? Yes. So I'm finished. Now, how to calculate? That's the next part. I am going to take my calculator and I am going to multiply everything on top. So on top I would do 24, let me write this up here, I would do 24.00 times 52. And I would get an answer on the top. And then I would multiply everything together on the bottom. And in this case, it's just 1. To find the final answer, you're going to do top divided by bottom. And that's how we're going to calculate. So the final answer is 1,248 weeks. Now, sig figs, we learned how to round, and we're going to do that right now. There is 4 sig figs in this number. Conversion factors, most of them are exact numbers. This one is exact, so we do not need to use it. So I'm going to round 1, 2, 3, 4. I should have 4 sig figs in my final answer, and my final units should be weeks. Awesome. A lot of times people like to draw this finish line or the final train track, letting them know that their units are good. That's kind of up to you. Some dimensional analysis steps require multiple steps. So let's look at that one. How many seconds are in 5 days? I'm going to go ahead and throw it on the screen. Take a second to jot it down. There's nothing on the bottom of our first train track. And then the next ones are all conversion factors. Days to hours, hours to minutes, minutes to seconds. Days is on top to begin with, so days needs to cancel. The equality is 1 day equals 24 hours. So I have a new unit, hours. but I'm not finished, so I got to move on. Hours needs to cancel to go into minutes. So my equality is 1 hour equals 60 minutes. Still not done. I got one more conversion factor. The equality is 1 minute equals 60 seconds, which allows us to cancel minutes. These are all exact conversion factors, so I'm not going to use those. It looks like I had a measurement here with 5.0. So in my final answer, I need two significant figures. And again, you're going to multiply everything on top, and you're going to multiply everything on bottom, and you're going to divide the two to get your final answer. And then the last one is going to be how many students are in a 10-room building if each classroom contains 25 students. So in the problem, it tells us a conversion factor. Don't know if you saw that or not, but it said each room has 25 students. That's called an equality, and we can use that as a conversion factor. So here we go. Nothing on the bottom of our first train track. I have 10 rooms. Here's my equality that I pulled from this problem. For every one room, 25 students, which allows me to cancel my units of rooms and go in to students. All of these are exact. 10 rooms is exact, 25 students exact, one room. I didn't need any measurements or equipment to measure these. So I don't need sig figs here. So I don't have to worry about rounding in this particular problem. Okay, that's all for this video.